example 12 wants us to solve for all x's between 0 degrees and 360 degrees, these different equations, and the equations are involving tangent. So we need to use what we know about the unit circle to help us out. We also want to work with our equation solving skills and so on. So again, be very alert to what the window they're asking you to answer. That's very key. So they're giving us 0 to 360 degrees. So our first equation is 3 tangent of x minus 7 equals 0. So we're going to solve for tangent. So we're going to add the 7 over, and we're going to get 3 tangent of x equals positive 7. And then we're going to get that tangent of x is going to be 7/3. So we want to find out when is our tangent 7/3. So let's see here. We're going to go to it. We're going to make sure we're in degree mode. And we're going to do the arctangent of 7/3. Voila. So we get 66.80 degrees. Very nice. So I'm just going to do 0.8, 66.8 degrees. So we get x equals 66.8 degrees. So we want to know when, are there any other places where this happens? And absolutely there are, because tangent, if we remember from our graphing and stuff, tangent has a period of 180 degrees, or pi. So it actually is going to repeat itself again on the unit circle for sure. So if we think about our unit circle, what we do is basically we're looking for 7/3. So we'll say it's like about that, because tangent, remember, represents the value of the slope of a line running through the origin. So we're looking for a line that looks like it's moving about 3 over and about 7 up. And so that's the same as if it was going back 3 and down -7. So you can imagine that those tangents are still the same. So basically all we have to do is add 180 degrees to it, and we're good. So 180 to this is going to be 246.8 degrees. Voila, done. And so we didn't know where that was on the unit circle, but we could figure it out pretty quickly. Our second equation gives us the tangent of x minus 65. So this is a little bit different because we now are, again, altering an equation that we have, an input that we have. So we get tangent of x minus 65 degrees equals -1. So this is a value that we can find on our unit circle if we want. Now remember, x has to be between 0 and 360 degrees. So x minus 65, okay, so remember, so x minus 65 has to be between 0 and, or x has to be between 0 and 360. So if we're taking 65 away from that, we can see that our answers could be anywhere from -65 degrees to 295 degrees. So these are answers that we could be expecting right off the bat. So we want to make sure that we fit this correctly, and then we can go and answer our questions. So again, we're altering our input, so we have to alter our window slightly. So basically all this is we took 65 degrees away from 360 and 0. So from here, what we're going to do is we're going to use our arctan, but we could also know this from the unit circle as well. If we did the arctan of -1, oops, it's going to give us -45 degrees. So we're going to get x minus 65 degrees equals -45 degrees. So this is the first place, okay? Now, at -45, it's going to also occur again 180 degrees away, right? So if you add 180 to that, so think of it like, again, we got -45 is here, boom, way up here. So that's 135 degrees. And so we could even go back again, you know, if you wanted to think about it, we could go back and add 180 to it. That would be 315 degrees, which since that's out of our window, we would remove it. So that's something to keep in mind. That's why adjusting your window can help, because now we wouldn't end up with an answer that we don't actually need. And so we get these 2 points, and now all we have to do is add 65 degrees to both of these. So we're going to get x to be 20 degrees and also 200 degrees. And again, that makes sense. They're 180 apart. They're going to have the same angle. But this becomes a little weird because we've altered our input. So just make sure that you're paying attention to your input and what your window is when you're doing these problems.